Good morning. I am Vaibhav Kumar Gupta, and today I am going to explain my project, Email Campaign Effectiveness Prediction. So, most small to medium-sized business owners use Gmail-based email marketing strategies for offline targeting and converting prospective customers into leads so that they stay with them in business. Our primary goal is to develop a machine learning model which can categorize the mail as it is read or it is ignored or it is acknowledged by the reader. So our dataset contains attributes as email ID, which contains the email ID of the customers or the individuals, email type. There are two categories, one and two. We can think them as a marketing emails or important updates. Then we have subject hotness score, which is basically the subject score on the basis of how good and effective the content is. And email, we have email source, which represent the source of the email like sales or marketing or important admin mails related to the product. Then we have a email campaign type, which is the campaign type of the email. Then we have a total past communication. This column contains the total previous emails from the same source and the number of communication it had. Then we have customer location, which basically contains the demographical data of the customer, where the customer resides. And we have then time email sent category, which it has three categories, 1, 2, and 3, which basically we can think of as morning, evening, and night slots. Then we have word count, which basically counts the number of words in the contained in the mail. Then we have total links, which contain the total number of links in that mail. Total images, which contain the total number of images in that mail. Then we have email status, which is our target variable here, which basically contains that whether the mail is being ignored, read, or acknowledged by the reader. So starting with our project, we have first imported our required libraries. Then we have a first view of the data set. So we can see that there are 68,353 rows and 12 columns. We have checked the duplicate values. There are no duplicate values. And we have checked the missing values where we can see that customer location, then total past communication, then total links, total images are having null values. So from the data set, we know that among the 12 attributes, there are 6 categorical columns, namely email type, email source type, customer location, email campaign type, time email sent category, email status, and rest others are the continuous variables. So when we check the unique variables, where we can see that total images to email status has 3 categories, email type has 2 categories, and time email sent has 3 categories, customer location has 7 categories, and email source type has 2 category, and time email sent has 3 category. So first we have drop email ID column, which basically doesn't make any sense for our clustering process, classification process. So we have drop our email ID column. Then we visualize our customer location for the different email status. So we can see that most of the customer resides in location G. Rather than that, we have like the ratio is being same in every location. We can notice here for location E, B, C, G, and D and F, there the ratio of 0, 1, and 2, the type of email status, the ratio is being same 80, 17, 4, 81, 16, 3, 81, 15, 4, 80, 16, 4, then 80, 16, 3, 81, 16, 4, 80, 17, 3. So basically the ratio is being same. So we can say that the relation with the email status is not too much impactful here. And then we have total path communication, so which we can see that it is normally distributed, kind of normally distributed, and most of the values lies between 20 to 40 here. And then we have plotted total links distribution, which we can see that it is kind of positively skewed data, where we can see that most of the values lie between 4 to 12, we can say. And then we have plotted email type for the different email status. So we can see that email type 1 is larger than email. We have email type 1 more than email type 2. Also, we can see that the ratio is approximately being same. So it may be like not too much impactful, for not too much related to our dependent variable. Then we have plotted email campaign for different email status. So it is from here we can see that the email campaign type 2 is highest, and 1 is the lowest here, and the ratio is not also same, and it is uneven here. We can see, notice here that the percentage of for email type 1, the percentage of email status 1 is higher, while in the rest 2 type, campaigning type, we can see that the majority is email status 0. So it may be like it is a, from this plot we can see that it is related to the email status somehow, so it may be useful. And then we have a email source type for different email status. From here we can see that the ratio is still being same, so it may be not too much related to the email status. Then we have plotted word count distribution, which is more kind of like normally distributed. So we check its relation with the email status. Then we notice that for email status 0, like most of the emails are ignored where the word count is higher. So, and for the rest too, we can see that the word count, average word count is low. So basically, we can conclude from here that longer mails no one like to read, and total images distribution, that we have plotted total images distribution. From here, we can see that it is positively skewed. Uh, so we have to check its relation with the email status here. It is not too much related. Then we have plotted subject hotness score. We can see that it is kind of positively correlated, positively skewed, and its relation with the email status. We can see that most of the emails which were ignored were having a highest subject hotness score. Then we have checked the email sent category for different email status. From here we can see that the ratio is being same, and the majority class for the type email sent category is 2. Then we have plotted email status distribution, which we can, from where directly we can see that it is a kind of imbalanced data set. So basically we can see the majority class 0 is having approximately 60,000 distributions and 60,000 observations, while 1 and 2 is having very less. So our problem will be a imbalanced classification problem. Then we have plotted our box plot, from where from where we can see that subject hotness score, total links, and total images were having some outliers. Then we have plotted the correlation heat map. From here we can see that email campaign type, then subject hotness scores, email source type, word count, total links, and total images are negatively correlated with email status. And email campaign type, then total past communication are positively correlated with the email status. Time, email sent category is not at all related with the email status. Then we have plotted the pair plot. So from the pair plot, we can see that total images and total links are highly multi-correlated, which we can cross-check here from the heat map also. So when we check the total links and total images, so we can see here the total images and total links is highly multi-correlated 0.78. Then we did feature engineering and data pre-processing part where we have to handle missing values. So basically we know that customer location, total past communication, total links and total images contains the missing values. So first thing is like the customer location is not much related with the email status. So we are directly going to drop this column. And for the total links, we fill the null values with mode as it is a categorical variable. Total images, we also filled uh, total images with the mode, and then we have filled the null values for the total past communication with the median because it contains some outliers, and we know that the median is the best for median is robust to outliers, so that's why we have fixed the we have filled the null values with the median. Then handling outliers. So here we have calculated the percentage of the majority class which will be affected by the outliers. So we can see that you have 11.45% of the majority class will be affected from outliers, and 9.58% of the minority class will be affected when we remove the outliers. So basically, we don't want to remove the outliers as it contains more than 5% for the minority class. Then we have encoded our categorical variables. Then we have did feature manipulation where we have created another feature email attachment from features total images and total links. So as total images and total links were highly multi-correlated. So then we have applied feature selection method where we have applied chi-square technique and mutual information gain. So from mutual information gain, we can see that total past communication, word count, email attachment, total links, and subject hotness score, email campaign type are the most important features. So we would like to drop the rest of the columns like total images, total links, email sent, time sent category, then email type. Then we have applied mean max scaling. Then we have splitted our data. Then handling the imbalanced data set. So basically we have applied random undersampling from where we can see that original safe was 54,000. Originally it contained 54,682 rows from where which can from where we resampled dataset contain 5,694. Basically it has undersampled the majority class here, and then we have applied SMOTE, which is an upsampling technique which generates the data synthetically. So after applying this mode, which we can see where we can see that it has changed to resample dataset shape has changed to 13,000 1,31,859. Then we have applied SMOTE data, which is a combination of both undersampling and oversampling. It is made up of from SMOTE upsampling technique, which is and TOMEC, which is undersampling technique. So Basically, it is a hybridization. Then we have implemented our first decision tree, first ML model, that is decision tree classifier. So the decision tree classifier with the on the original data, decision tree with the original data is giving a F1 score as 0.722. We will check the F1 score here as it is a kind of imbalanced classification here. So accuracy will be biased. So that's why we are checking for F1 score here. So the decision tree with the original data is giving 0.722 F1 score. Then decision tree with the random undersampling, it is giving 0.5609. Then decision tree with the SMOTE data, it is giving test F1 score as 0.713. Then decision tree with the SMOTE data, it is giving 0.713. Then we have applied hypertuning decision tree with the original data. We have used randomized search CV as it takes less time and it randomly choose from the all possible combination of the parameters from the parameter grid. So when we applied the hypertuning, we see that the F1 score has been increased to 0.744 on the original data. Then hypertuning the decision tree with the random undersampling data, which is giving 0.611. Then hypertuning decision tree with the SMOTE data, which is also giving 0.705 here. Then hypertuning decision tree with the SMOTE data, which is giving 0.689. Then we have applied random forest classifier along with original data, which is giving 0.7588. Then random forest on undersampling data, which is giving F1 score as 0.645. Then we have applied random forest on SMOTE data, which is giving 0.755. Then random forest on the SMOTE data, which is giving 0.754. Then hypertuning the random forest with original data, which is giving 0.745. Then hypertuning the random forest with undersampling is giving 0.6813. Then hypertuning random forest with SMOTE data, which is giving 0.712 as F1 score. Then hypertuning random forest with SMOTE data, which is giving F1 score as 0.7122. Then we have applied cat boost model. On the original data, it is giving 0.756 F1 score. Then cat boost on the random undersampling data, which is giving 0.6725 F1 score on the test data. Then cat boost on the SMOTE data, which is giving F1 score as 0.771 on the test data. Then cat boost on the SMOTE data, which is giving F1 score as 0.7698 for the test data. Then we have checked the feature importance using the cat boost model. So from here you can see that email attachment, subject hotness score, total past communication, word count are the most important features for our model. Then we have applied XGBoost classifier, which is giving F1 score as 0.726 for the test data. Then we have applied XGBoost on random undersampling, which is giving 0.638 for F1 score for test data. Then we have applied XGBoost on SMOTE, which is giving F1 score as 0.767 on the test data. Then we have applied XGBoost on SMOTE data, which is giving 0.768 F1 score on the test data. Then we have applied KN classifier on original data, which is giving 0.7561. Then we have applied KN on random undersampling data, which is giving F1 score as 0.6434 on the test data. Then KN on SMOTE, which is giving 0.654. Then KNN on SMOTE, which is giving 0.6515. Then hypertuning the KNN model on the original data. It has increased its F1 score to 0.757 on the test data. Then hypertuning KNN on the random undersampling, which is giving 0.662. Then hypertuning KNN on SMOTE, which is giving 0.677. Then hypertuning KNN on the SMOTE, which is giving F1 scores 0.657 on the test data. Then we have applied SVM model on the original data. We have from where we have got 0.732 as F1 score on the test data. Then SVM on the random undersampling, it is giving 0.676 F1 score on the test data. Then hypertuning the SVM model on the original data, it is giving 0.7326. So finally, we have collapsed all the models here, and it's like it's F1 score, precision, accuracy, and all. We have created in a tabular form. ROC, F1 score. So basically, we have plotted the F1 score for the test and train. So we can see that the cat boost with the SMOTE data is having a highest like F1 score, as well as we can see the lowest like F1 score for the train data. So basically it is less overfitting, and also it is giving the best result. So we have, on the basis of F1 score, we have selected the best model cat boost with the SMOTE data, as it has a higher F1 score on the test data, and it has less overfitting, and it has also a good ROC and AAC score as well. So concluding our project, basically we found that customer location feature not related to the dependent variable, so we have dropped it, and total links and total images were multi-correlated, so we created another email attachment. We created another feature email attachment which combines both of the total links and total images. Then we found that through the feature selection, that email type and time email sent category that are not related to the dependent variable. Also, we found that removing outliers would impact the minority class with more than 5% loss of the data. So that's why we decided not to drop the outliers. Coming to the model interpretation, for the modeling part, we found that SMOTE data was good for the most of the models. Then randomized search CV has been used for the hypertuning technique, as it takes less time, and for the modeling part, the cat boost with the SMOTE was giving the best result with 77.1% F1 score on the test data and 80.1% F1 score on the training data. So according to the cat boost model, total past communication, subject hotness score, word count, and email attachments are the most important features for the cat boost model. Thank you.